Okay guys, today's going to be a little long, but there's lots of good examples here, so just bear with me. Today we're going to be solving equations with all this exponent and radical stuff we've been learning about. And so the first one is, it has an x squared in it, and so does the second one. And then anytime you're solving these, you want to start by getting the x term completely by itself. So the first thing we're going to do in number 1 is divide by 3, and that gives us x squared equals 36. Okay? Now, to get rid of a square, we're going to use the square root. So I'm going to put that over my 2 pieces there, square root. And the catch here is that when you take the square root of something, or any other even root, you have to you get 2 answers, a positive and a negative, and in this case the square root is 6. So there's my final answer. It actually is 2 answers, and that just means both positive 6 and negative 6 would make the original equation true. Again, you always get a plus and minus anytime you take an even root. So a square root, a 4th root, a 6th root, and so on. Okay, moving on to example number 2. Again, we want to isolate the x squared. So we're going to subtract 1 first. And that gives us 2x squared equals 16. Then we still have to divide by 2. X squared equals 8. And then, like we said before, to get rid of a square, you're going to take the square root. However, 8 is not a perfect square root. So off to the side, I'm going to factor 8. And then I have to break down the 4. And remember, you're looking for pairs. So a 2 comes out, and then the extra 2 goes back under the root. All right, so your final answer is both positive and negative 2 square root of 2. The other option is to get a decimal, but right now I'd prefer you to practice breaking down the roots. Okay, number 3 has a cube in it. Well, we still have to isolate the x term, so we're going to start by dividing by 6. And that leaves us with the x cubed equals negative 216 in this case. And then to get rid of a cube, instead, like remember we got rid of the square with the square root, we're going to get rid of a cube with a cube root. Okay? I know that's really bad, but we'll get there. Okay, so we get the x we want. The good thing is, remember when you take the square root of a negative, you get an error? Well, you actually can take an odd root of a negative, 3 being odd. It just means your answer will be negative. And again, you want to break down the 216 and look for 3 of a kind. And I happen to know that 6 times 36 and 6 times 6 gives you all that you need. And so we get to take out the 6, and we are done. This time it only has 1 answer. So that's the case. With even roots, you have 2 answers. With odd roots, you're going to have 1 answer. Okay? Moving down the page, we have a 4th root, and that's okay as long as we isolate that term first. So we're going to divide by 2, and we get x to the 4th equals 81. And we're going to use the 4th root this time to get rid of the 4. So the x comes out. It's kind of like the 4's cross each other out, but over here we have to break down 81 and look for 4 of a kind. Well, I know 81 is 9 and 9, and each one of those is a 3 and a 3. There's my 4 of a kind. The 4 is an even root, so I have to put the plus and the minus That means I actually have 2 answers. The good thing was nothing was left over. Okay, now sometimes these powers are outside of parentheses, and if that is the case, you have to actually get rid of the power before you can get rid of the parentheses. So we have to make sure everything in parentheses is completely by itself, and then we can get rid of the exponent. So in number 5, we would take the square root to get rid of the square. That kind of cancels out. And I'm left with the x plus 5 that I wanted. Having trouble here. But it was an even root, so we get plus and minus, and it is still the square root of 21 because 21 does not have any pairs in it. Now, I have to subtract the 5 over, and since 5 does not match the square root, we actually put it in front of the plus and the minus. And that is our answer, all of it. That is 2 answers, -5 plus the square root of 21, and -5 minus the square root of 21. All right, in number 6, we have a similar problem, except we have to get rid of the 6 first. So we divide by 6, cross that out, and we have x plus 3 raised to the second is equal to 4. Because it's a square, we have to use the square root to get rid of it. And that gives us the x plus 3 out of the parentheses. But the square root of 4 is plus and minus 2. And then we have to subtract the 3. But be careful here, because we get -3 goes first, then your plus and minus 2. However, because there are no square roots left, we actually need to put these numbers together. So I have -3 plus 2, and I have -3 minus 2. So this time I get 2 answers, but I actually had to work them out. All right, let's move down the page. Again, I've got some parentheses, so I want to isolate them first. So I add the 1. That gives me the parentheses by themselves with a power equals 81. To get rid of the power, I have to take the 4th root on both sides. That gives me the x minus 4 out of parentheses. The root is even, so I have to put a plus and minus. And earlier we worked out the 4th root of 81, and it came out to be 3. So I already know that one's going to be 3. Then I have to get the x by itself by adding 4. Anytime there's a plus and minus, whatever you add goes in front of the plus and minus. And since neither one have a square root anymore, I actually have to work out 4 plus 3 and 4 minus 3. So my 2 answers are 7 and 1. All right, number 8, we have several things to move before we can get rid of the cube. The first thing that has to go is the 3, so we subtract. We bring everything else down, and we equal 64. Then we divide by 2, and we bring everything else down, and we equal 32. And now we have to get rid of the cube, and so we're going to use the cube root. Now remember, the cube root means when you're going to break it down, you're looking for 3 of a kind. So off to the side, I'm going to do 4 and 8. 4 is 2 and 2. 8 is 2 and 4. And the other 4 is another 2 and 2. So I do have 3 of a kind, and that comes out. but I still have something left over, so I have to make my cube root again. 2 times 2 goes back together. Now, I do not need a plus or minus because the root was odd. And to finish, I add 4. Now, these are not like terms, so I'm going to put the nicer number in front for plus, and then the 2 cube root of 4 comes along for the final answer. All right, let's move on to the back. My powers change just slightly when I get to the back. They are now fractions or rational exponents. And we're going to start the same way. We're going to make sure that that's by itself. And then we are actually going to raise it to its reciprocal, because a fraction times its reciprocal cancels each other out. So in number 9, just so I have more room, I'm going to rewrite my x to the 2/5 and my 2. But to get rid of the 2/5, because it's a fraction, I'm going to raise it to the reciprocal. And remember, in algebra, when you do something to one side, you have to work it on the other. So the reciprocals basically cross each other out. And I'm left with x equals 2 raised to the 5/2. Now, depending on if it's a multiple choice question or how the directions say to write your answer, you can either leave it like that, convert it like we learned in an earlier lesson. The 2 on the bottom tells me that it's the square root, and then I can have 2 all raised to the 5th, or I could even type it in the calculator. But if you do that, I recommend you keep 3 decimal places. This one would come out to be 5.657. Okay, in number 10, I have a very similar problem, except I have to divide by 2 first. That allows me to get the x term completely by itself. And then, because of the fractional power, I can raise both sides to the reciprocal. And this one I'm just going to type in my calculator because it works out very nicely to be x equals 25. All right, number 11 is just slightly different because I have a fractional power on one side and not on the other. But it is in parentheses, it is by itself, so I am going to raise it to its reciprocal, which in this case is 2. Now, if I raise one side to the reciprocal, I have to raise the entire other side to the second. Well, reciprocals cancel, but on the other side, I actually have x minus 4 squared, which means I really have x minus 4 times x minus 4 equals the 2x. Well, there's a problem here. I actually have to multiply that out, and so I have to FOIL. First gives me x squared, and outer gives me negative 4x. Inner gives me negative 4x, and last gives me positive 16, still equal to 2x. Combine my like terms. But if you will remember back to Unit 3, when you were solving with trinomials, it had to equal 0. So I have to subtract the 2x. All right, what happened here? I lost my thing. All right, so I have to subtract 2x from the 8x, and that gives me x squared minus 10x plus 16 equals 0 now. And then I have a trinomial that I have to unfoil. The signs are the same because of the plus, and they're both minus because of the 10 is negative. And what multiplies to be 16 and adds to be 10? That's 2 and 8. And remember, when you're solving problems like this, you have to set each piece equal to 0 and solve each piece separately. So I'm kind of running out of room here, and I get 2 answers. Okay, let's slide on down. We've gone through the powers that are fractions. And now what if I have a root instead of an exponent? Well, I got rid of exponents with roots. So now I'm going to get rid of roots with exponents. However, you need to make sure the root part is by itself. So I'm going to minus the 2 and get the square root completely by itself first. And since it's a square root, I am going to square it to get rid of it, but you have to square both sides. So I get the 4x from minus 7 from underneath. The square root's gone. And 3 squared is 9. And now it's a very basic algebra problem. You add 7, 4x equals 16, and divide by 4, and x equals 4. And there's no plus and minus on these. Okay, there's no plus and minus on these. All right, well, sometimes there's a square root on both sides, and that's okay as long as they're on separate sides. You start the same way. To get rid of it, you square both sides. Okay, so the 3x plus 2 comes out of the square root. So does the x, but be careful because you actually have to square the 2 and get a 4. Now, since there's no x squared, we just need to get the x's together. And 2 equals 1x. And we are done. Okay, now, problem number 14 is slightly different than 13 because they are not on different sides. So the first thing you want to do is if 1 is subtracted, that'll be easy, you add it because they have to be on separate sides. So we get 3 square root of x equals square root of x plus 2. Now they're on separate sides, and again, to get rid of a square root, we raise to the square. That gets rid of the square root on both sides, but don't forget that means you actually have to square the 3 because it was not under the square root. And to finish, I'm going to get my x's together. That gives me 8x equals 2. And then I have to divide by the 8. And hopefully you know that that's the fraction 1/4. Okay? And the last one has a cube root in it. So just like before, we're going to isolate the root. So we have the cube root of x equals 4. And to get rid of the cube roots, we're going to raise it to the 3 on both sides. That gives me the x I want. And then I work out 4 cubed, and I'm done. Okay, I know that was kind of long. I appreciate you staying with me. We will practice this in class tomorrow, but please make sure you bring this with you.